Okay, today's lesson that we reviewed was the law of sine and cosine. And so, Keaton, I'll just have you explain the problem you worked and what your strategy was.
Okay, so the problem here provides us with triangle ABC, and it gives us the lengths of all three sides, but the lengths of none of the inside angles. And it asks us to find first angle A and then angle B, and then it asks us something about the nature of the whole triangle. Now, thanks to the law of cosines, we are able to find the measures of these inside angles, but without the law of cosines and sines, we would not be able to find these inside angles because we only have the lengths of the outer side. So the law of cosines is a squared equals c squared plus b squared minus 2cb cosine a, which is pretty much the Pythagorean theorem, but because this is not a right triangle, we add on this end bit here. In fact, this end bit is actually always here, but it just equals 0 on a right triangle because of the nature of the 90 degree. So we use that template and just fill in our information here. So this is just filling in the information from the upper triangle here. And then we just apply some basic algebra here. I believe just here I've just been going through, adding it all together. Apply basic algebra here, go through, and eventually we get cosine A is this number. So we have angle A equals this, which actually is 30 degrees due to the approximations of the calculator. So it's angle A here equals 30 degrees. So we can write that in.
Okay, so I want to ask you a question. Yeah. If you have the cosine of A happens to be that ratio 0.8660,
right,
what concept are you using to find out the angle?
Well, we're using the arc cosine, which is just you go on the calculator, enter this, and then go to the second function or inverse function of the cosine, which will just give you the arc cosines. Because we know, if you know the value of the cosine, thanks to tables that have been built by mathematicians, we know what the what the actual angle is.
Okay. So now we have what? We have a side angle side situation. So when we're in a side angle side, and now you need to go find another angle, did you use the same strategy or a different one to shoot for angle B?
Well, we could use the same strategy, but it's a lot easier to instead use the law of sines, which is just, it's a bit simpler than the law of cosines. And it says that the sine of angle A is to the length of side A, which is just opposite the angle as sine B. You can see it right here. I'm not going to say it all out. So that's the law of sines. So now they ask us to find angle B. So now I just set up our ratio here. The sine of 30 degrees is to side A, which is 780, as sine B is to 1351 here, the length of side B. So then we just do some algebra here, go through, and we discover that angle B is equal to 60 degrees. So we can come in here and write that. Now, at this point, we should recognize that something is special about this triangle because all the interior angles, the sum of the interior angles of any triangle is always 180 degrees. And this is 30, 60. So it should be natural to write 90 here, 30, 60, 90. Because that all adds up to 180 degrees. And 30, 60, 90 is a very special kind of triangle because with those measurements of the inside angles exactly, that means that their opposite sides have a very special relationship of their ratios, which is this. In a 30, 60, 90 triangle, the shortest side is 1/2 as long as the longest side. So it's a 2-to-1 ratio here. 780 times 2 is 1,560. That's true of all 30, 60, 90 triangles. This is 1/2 the length of this.
What about the other side?
The other side is the shortest side times rad 3 is the length of the middle side. So I also wrote that here. And then now, I should have initially, I did not realize this initially when solving this problem, but I should have recognized the ratio of the lengths here, this 2-to-1 ratio, because 780 times 2 is 1,560. Had I recognized that, I should have known it was a 30, 60, 90 triangle and eliminated the need to find those interior
angles.
Through the law of cosines and sines. Through the law of cosines and sines, but it's pretty cool method anyway. So
good. Thanks a lot. Job well done. Thanks for your explanation.